Okay, and we're back to do another Introduction to SPSS tutorial. This tutorial is going to cover independent samples t-tests. So for this tutorial, we're going to use our biker data set again. And so what's good to remember is that an independent samples t-test is going to compare two groups of different individuals or different observations to see if those groups come from the same population or whether they come from different populations. And our null hypothesis is going to be that the groups are part of the same population of individuals on whatever our outcome measure is. Okay, so for the example research question we're going to use, let's say we wanted to know whether individuals who ride biker bikes or Harleys get different numbers of citations or more citations than individuals who ride street bikes, right? So remember that in our motorcycle variable, our two groups are biker bikes and street bikes. So this represents the type of motorcycle that people ride, okay? And let's say specifically we're interested in whether this was different in the year 2013. So we're going to examine the number of citations for each of those groups of bikers from the year 2013, or from the data that was recorded in 2013. So one thing I want to point out at the beginning that's important is that in my grouping variable, in the variable that represents the group that my participants belong to, it's important that I know what number represents either of my groups. So in the current data set, a 0 represents the biker bike group, and a 1 represents the street bike group. That's going to be important to know once I actually do the t-test, okay? But I just wanted to point that out before we get started. Okay, so in order to do the independent samples t-test, I would go up to Analyze, go to Compare Means, and the third option down is Independent Samples t-test. So I select that option, and so as usual, all of my available variables are over here in the box on the left. Over in the box on the right, so I have one big box on the right, that's the test variables. Test variables represent your outcome or your dependent variable measure. So it's going to be the continuous variable that you want to compare across the groups. And then down here we have a grouping variable box. That's going to be the nominal variable that's going to contain the categories that you want to compare on the test variable, right? So as we stated in our example, let's say we want to compare the number of citations in 2013 across our two motorcycle groups. So I'm going to move the number of citations in 2013 to the test variable box, and I'm going to move motorcycle into the grouping variable box. Now I have to do one other thing here. I have to explicitly tell SPSS which groups that I want to compare. Okay? That might seem like a silly thing to do since I only have two groups. But what you can do in SPSS is you can use a nominal variable down here that has more than two groups as long as you tell SPSS which groups you want to compare to each other. You can only use two groups for an independent samples t-test, but SPSS will let you choose those two groups from a variable that has more than two if that happened to be the case. Now our motorcycle variable only has two groups, but we still have to go in and explicitly tell SPSS which groups we're going to compare. And that's why I had you look and note which numbers those groups were represented by at the beginning, because that's what we have to enter into this box here. So when I click Define Groups, I want to say that Group 1 should be 0 and Group 2 should be 1. That's telling me that that Group 1 should be my biker bikes group, and Group 2 should be my street bike group. Okay? Click Continue, and let me see if there's anything in the options. Options is really going to be for confidence intervals, which we're not going to worry about too much right now, so we won't do anything with that. Let's click OK, and we get our output. So we get two boxes of statistics from doing this type of analysis. The first box, the group statistics box, gives me my sample size, my means, my standard deviations, and my standard errors specific to each group, right? So what this tells me is that I had 60 participants in each group, so 120 participants total. I had 60 in the biker bike group and 60 in the street bike group. The mean number of citations in the biker bike group was 4.35, and the mean number of citations in the street bike group was 3.30. And then you've got the standard deviations and the standard errors associated with both of those groups. Okay, so that's just more descriptive information. Then down here in the independent samples t-test box, we get the information that's relevant to our hypothesis. So you get a lot of information here, and at a beginning level, some of this is going to be necessary and some of it isn't. So let me start by explaining what's over here in these first two columns, which has the heading Levine's test for equality of variances. So this is probably a little bit advanced. It's not something that I generally talk about in class very much. But just to let you know what this is a test that's examining whether the variability is the same across both of these groups. An assumption of an independent samples t-test is that you're going to have about the same amount of variability in the two groups that you're comparing. This test is testing whether that's the case. If you get a value in this significance box here that is less than 0.05, that means that your groups have unequal variances. And what would kind of indicate that here is the fact that the standard deviations and the standard errors are somewhat different between these two groups. Okay, so this test down here confirms that there is a difference, that the groups do not have equal variances. And to an extent, that gives us problems when we want to do an independent samples t-test. So that's why there's two rows here in the independent samples t-test box. The equal variances assumed row is what you use if you do have equal variances across your group. So you would use that if this significance value was greater than 0.05, and the equal variance is not assumed makes an adjustment if the variances across your two groups are different. And you would use this row if this test is indeed significant, which it is. Now, that's very appropriate use of statistics. That's very specific and detailed, and somebody doing really, really good statistics would pay attention to this and would decide which of these rows to use depending on whether the variances were equal or not. I don't want to spend too much time on this. What I usually tell beginning students, and what usually happens in practice when we read published research, and you can decide whether this is appropriate or inappropriate, most people just use this first row no matter what. Most people ignore this second row, and usually with introductory students, I tell them to do the same thing because it can get really confusing to try to understand what's going on here. So for all intents and purposes, there is a difference here, but a lot of people just use this first row, and I'm going to tell you to just focus on the same thing right now, because essentially, even if we look at our values here, there's not much of a difference between them anyway. Okay? So that's all I'm going to say about that at this point. So for the rest of the time, I'm going to just speak about the statistics in this box in terms of what's in this first row. Okay? So this t column is your observed t-value. So our observed t-value here is 3.407 or 3.41. The overall degrees of freedom is 118. My p-value, my significance value, is 0.001. Okay? That's definitely less than 0.05. And so based on that significance value, we would reject our null hypothesis, and we would conclude that these groups are actually different in terms of the numbers of citations they get. All right? And so once we know that there is a significant difference, once we know that we're rejecting our null hypothesis, we can go back up here to the group statistics and see how to interpret that. So we're concluding that the groups are different, and specifically the means tell us that the biker bikes got significantly more citations in 2013 than the people in the street bike group. Okay, so that's what the conclusion that we would draw, that people that ride the tough Harley bikes get more citations per year than people who ride the street bikes. Okay, again, no offense to any bikers, this is all made up data, and I wish I could ride a motorcycle, but that's for another time. So the rest of the statistics down here are just kind of good information. The first box is your mean difference. So this is just what you get if you subtract 4.35 minus 3.30. You get 1.05. The standard error of the difference is what you would get if you calculated by hand, the standard error of the different scores. And then your 95% confidence interval is your 95% confidence interval of this mean difference. So this is the mean difference we observed in the sample. This is telling you we can be 95% confident that the real population mean difference falls somewhere between 0.44 and 1.66. What I'll point out here is that both of these values are positive. There's no zero included in this confidence interval, and that's generally going to be the case when you have a significant, when your statistical test indicates a significant difference. All right, so this mean difference here, we're very, very confident that it's greater than zero, meaning when we take the biker bike group, subtract the street bike group in the population, we can be 95% confident that we're going to get a positive value there, meaning that the biker bikes, people who ride the Harleys and the biker bikes are going to get more citations than the people who ride the street bikes. Okay, but that's just a different statistic, a different way of thinking about this test. Okay, so in a nutshell, what we conclude: people who ride the Harley biker bikes are getting more citations, at least in 2013, than people who rode street bikes based on the data in our sample. All right. In a later tutorial, I'm going to cover correlated groups or paired samples t-tests as well, but that's all we're going to talk about for this tutorial on independent samples t-tests.